Welcome back to episode 5, everyone, and we're heading into part 2, the second video, where we're going to learn all about the inner join. In part 1, we had a good look at the select statement, a run through like an introduction, and we'll be building on that knowledge to show you how to join two tables together. Why would we want to join two tables together? Well, what databases are relational. So if you imagine a scenario where you are building a database for a internet sales system, you of course want to have some customers for your database to sell your products to. So straight away you have a customers table. You know you have to build one of those. And of course, in order to sell products to your customers, you'll need a products table. So there's two tables that you'd need to create straight off the bat. And of course, if you're conducting sales between customers and yourself using your products, you probably need to put in some sort of sales tables. Now, how do those all join together? How do they relate with each other? Well, normally you'd have what's known as ID columns. So these columns link the two different tables together. So customers would have a customer ID column, and your sales table will have a customer ID column as well. And those two will be linked. And then of course your sales table will have a product ID column, and your product table will also have a product ID column, for example, and so you can relate all those together. And when you select from those tables and you join them all together, you can actually tell which customers ordered what products. That's the great thing about relational databases. So we're going to learn how to do just that. Let's head on in to SQL Server Management Studio. However, before we begin the actual lesson itself, as promised, we're going to have a look at the examples that you were given at the end of the first video. So before we even begin, we need to make sure that we are using the correct database. As you can see here, it's got the master database. That's currently the one that all the code in this query will be running against. So we need to switch it to worldwide importers. So I'm going to highlight that, hit execute, and off we go. We're now on the right database, so now we can crack on with the examples themselves. Now the first one was all about pulling all the data from the stock items table. We needed to also include a filter in the where clause of the supplier ID equal to 7, and then right at the end we needed to sort the results alphabetically by the stock item name. So this is how I went ahead. Here's my code. Select star from the stock items table. We can see it in there, and in the where clause where supplier ID equals 7, and we order by the stock item name. So let's have a quick look at the table very quickly, the structure. So here's our supplier ID. That needs to equal 7 to fulfill that filtering requirement, and of course stock item name is what we're going to sort the results on. So let's have a look at our results. If we highlight that block of code, hit execute, and there we have it. Our supplier ID is only equal to 7, and we've got 67 rows down there. Not only that, our stock item name is sorted alphabetically, starting with numbers as we go down into letters all the way down to V, the last one. So that is that requirement fulfilled. Now if your code was slightly different and you didn't get those results, don't worry too much about it. Just have a look at the example I've written and I'm sure everything will fall into place. Example 2 then was all about the Banana USB flash drives. We need to pull all the data relating to those from a specific table. Now, we were given a hint here. They were after invoice line data, so we needed to look for a table roughly along those lines. And of course, up here in sales, we've got the sales.invoice lines table. So all we needed to do then was simply extract all the data from the invoice lines tables, as you've seen there. However, they only wanted the ones where the description equals the USB food flash drive banana style. So if we had a quick look at the table itself once again, you can see under description it's got the USB food flash drives in there. A quick look at that would have told you exactly which table, which column I should say, that you needed to filter on, which is the description column. And there we have it. We filter the description by this string. Up here it's listed out in full, so you could have simply copied and pasted that down there, but making sure once again that because it's a string, you put the little inverted commas at the beginning and at the end. Unlike at the start here, supplier ID, as you can see there, it's an int, an integer, so we just had to put the number 7 down. No need for inverted commas. Description, however, is a varchar type, so we needed to put it in inverted commas. So once again, let's run that off quickly and see what we get. 1061 rows, all the data presented. Here's your description, USB flash drive banana, and if we scroll down we can see that it's all the same. So we filtered correctly and returned all the data, fulfilling that requirement. Number 3 then was all about the annual bonuses that we're getting paid in our end of year paychecks. Fantastic stuff. We're already told the table to use, so that was pretty straightforward. So having a look up and down, we see application people. Here's the table, here's your schema, the table name, so we know that we're in the right table. However, we needed to ensure that we selected employees only. So that was a bit of a tricky one to get your head around. If we have a quick look at the table itself, it's a bit hard to tell who's an employee, who is not, until we get to this column here, is employee. Now you can see that's a 0 or a 1. If we scroll down to is employee, you'll see that it's a bit type, which can only be, as we know, a 0 or a 1. So what that says to me is if it's a 0, then it isn't an employee. If it's a 1, then it is an employee. So that's our filter there. If we go back to our example, that's how I've done it. I've said where is employee equals 1. Now that's pretty standard sort of example for you, where they've asked is employee. If it's a 1, it's true. If it's a 0, then it's false, and they're not an employee. So that's pretty standard going forward with all these type of flag type columns. Bit columns are very useful in flagging items either true or false, and very easy to use, and you'll probably see them popping up regularly when you start developing yourselves. So let's see what we get. Where is employee equals 1, execute the code, and I've got 19 rows. And once again, you can see we've got all the data pulled across, ready for payroll to have a look at and grab what they need from it. and of course is employee equals 1, it's all 1. So we know that we are only sending employee data to payroll. That's what I've got for you, everyone. Those are the 3 examples. I hope you've got a lot out of those training yourself, and you can see from my examples there, you can see where you've gone wrong, or even better, where you've gone right. Alrighty then, now that the homework is out of the way, let's head on in to the lesson itself. I've prepared a script for you all here, but for you, if you want to follow along, just simply fire up a new query with the new query window up here. Fantastic. Right, so very first thing, just to make sure that we're using the right database, either highlight the command there and click execute, or just double check that you've got the right database showing up here on the left. Once you are in the right database, let's crack on with what the inner join is all about. So first thing you'll notice is there are actually 2 ways to name the join. So we're looking at either typing out inner join, or you can simply type out join to link the 2 tables. Now this functionality is exactly the same, and it boils down to how you prefer to write it. Personally, I like to write it out in full like that, just to make sure that I know exactly what join type it is, because there are more than one. Straight away at a glance I know what I'm using there. So to begin with, we start off with our select star. That'll get us going on our query, and of course then we need to select from our table that we want to use, not forgetting to put the schema with a dot and then the table name there. If I hover over the mouse, you'll see it says table and schema there. So we know we're selecting star from that table. So what is it all about when it comes to the join? As we know, we have got many orders within the orders table here. Now, if we wanted to bring in the invoices for each order, which are sitting in another table, we need to somehow link the 2 together in order to pull the rows across that are matching. So what we then do is we type out inner join underneath, that sets the join type, and then we say what schema and table we want to use to join onto sales orders. So once we've specified both tables that we're going to be using in our join, we then need to tell SQL Server how exactly we're going to go about joining the 2 tables together. And bear in mind, if we want to join these 2 tables together, they have to have a link between the 2. Somewhere in the table there will be columns that we can use to link the 2 together. Now, not every single table in a database will be able to be linked to every other table in said database, but you will be able to connect them all in some shape or form. Just like we saw on the database diagram in the first video, you can see there's a lot of links between the different tables. It can look like a bit of a crazy wire diagram, but once you understand the concept, it starts to make sense. So let's go ahead and join these 2 tables together. We then write the term on, and that specifies to SQL Server that we're now going to present it with the columns that we're going to join on. So let's have a look at our sales order table quickly. I'm going to highlight that, press Ctrl 3, and there you go. There's various ID columns. Now, ID columns are normally used when they're going to be used to link to other tables. That's a pretty common feature with SQL databases. Now bear in mind that these could be named anything and everything, and it depends on the database itself and your knowledge of that database to build up on how they link together. So as you can see here, we have an order ID column, and it's just numbered 1, 2, 3, 4, 5, 6, 7. Control R to get rid of those, and let's have a quick look at our invoices table. There you go, invoice ID, all manner of other IDs, but we have an order ID column as well. So, thinking about that logically, we can assume that those two columns join together. Order ID in invoices to order ID in orders. So, let's put that to the test. After our on command there, we then have to specify schema, the table and the column that we're going to firstly join with from the one table, and then we type our equals, and then again the schema, the table and the column, which again is the order ID from the table above. So we make sure that we're telling SQL Server join these two tables on these two specific columns. Now it doesn't matter which way around you put these in. You could put the sales orders order ID here equals sales invoices order ID here. It makes no difference. Personal preference for me is to put everything related first in the command and then joining to the other table, which is our sales orders, after the equal sign here. But again, purely up to you, and it doesn't make any difference on the results and the way it works. So we have successfully written the code to join those two tables together. Let's have a look. I've put in an order by as well, just to see the results easily, and let's see what happens when we run that code. Okay, so here is our result set. Quite a lot of data being pulled with the select star, and as you can see, first table, our sales orders table, is represented first in the data. So all of this data here is from our sales orders table. Now if we scroll along to the right, keep going, suddenly we hit the invoicing table, the invoices. So all the data from here on in does all belong to the invoices table. So what it's doing is it's showing you the entire table with the second table to the right where it's linked. And we can see here on the invoices table we have an order ID of 1, so it's pulling it on the same row in our results as the orders table in order ID 1. So we know that our link has worked in this case, and we can tell that invoice 1 relates to order 1. So we've successfully joined those two tables together. Let's have a quick look at the amount of rows returned. You see there's 70,510. And this is important to note because what the inner join does, and this is the key feature of this very popular join, probably the most well-used join in SQL servers and databases. What it does is it'll only return results in your result window when there is a link between the two tables being joined. If there isn't a link, it simply won't pull any data at all from either of the tables. So let's have a quick look. 70,510, remember that. If we just pull all the orders from the orders table itself, as the query runs, we get 73,595. So there's 3,000 more rows, there's 3,000 more orders in the orders table than there are invoices. And this is because normally when an order is placed, it then goes to the warehouse to be shipped out, and then once it's been shipped, it is invoiced to the customer. In this scenario, we can see that there's several orders that have been placed but haven't been shipped yet, around 3,000 of them. So the inner join will get rid of any orders and invoices joined together that haven't been shipped yet. And that's the main thing about the inner join. It'll only return results if there is a join between both tables. Let's have a quick look at an order ID I've pulled up earlier in our where clause. And remember from the first video, our where clause is like a filter on our result set. If we include that in there and we select that, as you can see, nothing is returned, just the headers from both tables. But there is no data. And why? Because while this exists in our orders table, this order ID does not exist in our invoices table. And so that is why we do not see any data coming through. Let's have a quick look at that in a diagrammatical form. We'll have a look at what's known as a Venn diagram, and it should hopefully explain the join in a little bit more detail and hopefully make it clear to you on what's going on. So on the left we have our order table. As you can see, we've got our order ID, customer ID, etc., etc., and that's represented by this big circle on the left. And on the right we have our invoice table, where we've got our invoice ID, etc., and we've got our order ID column here. So as we've discovered, this order ID column links to this order ID column here. And that, of course, the invoicing table, is represented by this huge circle on the right. Now, what the inner join will do is it will pull all the results that have a link. So in yellow, all the overlaps between the two tables. So they must have a link. So our results are, as you can see on the bottom, order ID, etc., etc. Now, if you look at the little table on the left here, you'll see there are 10 records. However, on the output, there are only 7. And this is because on our invoicing table we have here, there were only 7 records. So from 587, 588, and 589, those orders were missing from this table here. So there will only be 7 records output on our select statement. So that's the key thing to remember, is that with the inner join, records have to exist in both tables and have that all important link between the two tables itself for your results to show when you execute your select statement. That's the key thing about the inner join. Right then, let's work a little bit more on the inner join itself, and as you can see, I've prepped a little example for you here if you want to give this a go. So basically there's been a bit of a mix-up with a recent batch of orders that have come in from our suppliers. So the purchasing manager has asked you to provide her with a full list of all purchase orders and the matching order lines. So you need to extract all the data from these two tables. Heading over to the Object Explorer on the left, we can see our two tables here. We've got purchase orders and we've got our purchase lines. So if you want to give that a go, hit the pause button on the video, try typing out the code yourself, see if you can get the gist of what's going on, and we'll go through the example in a moment. Okay, so first things first, to begin our query, we always start off with our select star. Once that's in, we need to then go with the from, because we're going to pull the very first table itself. So, which one do we pull? Orders tends to be the overarching sort of header table, and that's subsequently broken down into order lines. So I would normally take the header table first, but it doesn't really matter because we are inner joining the two tables together. It doesn't matter which order you place them in. So we've got our first table that we can see from the requirement here, the purchase orders, and now we need to join it to bring in matching order lines against each order, and we're going to do that with the inner join. So our second table is the order lines. Let's click and hold, drag it across, release the mouse button, and we've got our second table in there. Right, so we know that we've got our two tables, purchase orders and the purchase order lines. So then we need to join the two together. Right then, what's the next bit we put in? Is the on, and now SQL Server knows to expect the two columns we're going to join on. Let's grab that bit of code there. So we've got the schema and we've got the table, and as you can see it comes up with a red error because it doesn't know which the rest of the expression itself. So let's have a look at our order lines table very quickly. You can see that it's got a purchase order ID along with supplier ID, etc, 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 but more than likely the purchase order ID will be what we're going to join it on. Control R on those results. Let's Control 3 on the purchase order lines, and once again we've got a purchase order line ID and various other IDs in there, but there's our purchase order ID. So we've got our joining column between the two tables. Control R on that. So we'll continue typing, full stop. If you open your square bracket and it was the purchase order ID, you can use the mouse arrows or the cursor arrows or the mouse to move up and down, and we're going to select that one. Just double click on it and it fills it in for us and even puts in the square bracket at the end if you put the square bracket at the beginning. Now it's still got the red squiggle lines, and that's because it's expecting the rest of the statement, which is the equals part. So we're going to put the equals in and the red squiggles disappear. So now we know we're going to link the purchase order ID from the order lines table. What we're going to link it to is the orders table. Let's just copy that one, paste it there, and we can also simply highlight this block of code with the full stop, Control C to copy and Control V to paste. So we've got our linking column in here, as you can see hovering over the mouse, this column, and we've got our linking column in here, which is purchase order ID. Here's our table, purchase orders. Here's our other table, purchase order lines. So looks like our query is good to go. Let's run it off and see what results we get. I've got 8,367 rows. Hopefully you guys have got the same. I'm sure you did. And you can see how easy it is to put together a basic inner join query. Now, one thing you'll notice, if I grab all the rows from our purchase orders table, there is one purchase ID per order ID. So it goes 1, 2, 3, 4. So all these orders are unique. However, when we ran off this query here, you can see suddenly there's 3 order IDs showing in our orders table. As we scroll along and we get to our orders line table, this is the data coming in from the purchase order lines, we can see that again, the purchase order ID, we've got 3 1s in there. So is that 3 orders? Well, it's one order, but it's got 3 different purchase order lines to it. As you can see, these are 3 different items. You've got variety, male, female, of the action figures there. And that is why it is showing 3 purchase order IDs for order 1 from the orders table, as you can see there. So it's linked to everything correctly. However, there's 3 order lines for that one individual order ID, which is why it's pulled 3 different rows for order ID 1. And of course, for the remainder of the rows, it just duplicates the data in the orders table, as you can see here. All this data from the orders table is an exact duplicate of itself. But when you get to the order line table, the data is all different there, as you can see. So it's just one thing to be aware of when you join tables together. Depending on what granularity they are, you may start getting results like this, where it looks like there's a duplicate, but it's actually working in the correct manner. So how did you all do? I'm sure you did fantastically well. Let's move on to the next section I've got for you here, and that is using joins, filters within joins themselves. So looking at the simple query that we had up top here, sales orders, sales invoices, and we joined them on the order ID. If you remember, what we're going to do is we're going to put in a where clause where the year of the invoice, which is invoice date, which is taken from this inner join table, is equal to 2014. Don't worry about this function at the moment. All it does is pulls the year from a date field. We'll be covering this in a later episode. Suffice to say, all this is going to do is pull all the orders that have a matching invoice, remember, because we're inner joining, and the invoice date is 2014. So everything that was invoiced in 2014. Let's see those results. And if we scroll across, here's our orders data, of course. As we scroll across, we get our invoicing data. So we're going to have a look at the date, invoice date 2014. As we scroll down, you'll see the date is all 2014. So that's your standard filter in the where clause. It has filtered the results in our second table that we inner join from. So you can use that method there. Now there is another method of filtering, and that's within the join itself. Because we know that in the where clause that this invoice date resides within the table that we're joining to, we can then simply bring in this little bit of code here. So let me pull that across for you quickly, and I'll make sure that we have it written correctly for you. So instead of the where clause, we can simply say and we repeat exactly the same code for that filter there. So instead of a where, which goes after all your tables that you're joining and selecting from, instead we're actually putting this within the join itself. Now, as far as the time taken to run the query off, you'll see that it's pretty much the same thing. And when we inner join, it's fine to do this, and you'll receive exactly the same results, 20,303 rows. There we go, easy done. So what this means is that you can do your join within, you can do your filter within the actual inner join itself, or you can do it in the where clause. As long as you do it within the join, you can then specify the and filter it there. What you can't do is put your join in your table that you're selecting from, your main table itself. Okay, it gets very, very confused. So if you've just got one table that you're selecting from, you cannot filter when you use the command from. You have to put any filtering within the where clause itself. As you can see here, let's tidy that up for you. We put it in the where clause. Select star from, then you use the where. However, if you are joining, you can of course put a filter within the join itself. And again, when you're using the inner join, you can do this quite comfortably, and it will return exactly the same results if you do it within the join or you put it in the where clause. And you'll find that most of the time it takes to run either query is about the same. Sometimes SQL Server can get a bit confused and one way will be quicker than another, but you just have to play around and see the results you get from there. So within the lesson, we've had a quick look at the inner join itself. We've gone over the basics and with a quick example to help you get your head around that. Key things to take away, of course, when you're using the inner join is to write the on, and then you bring in your columns, equals, and then the column that you're joining to within the other table. And we've also covered filters within joins. So if you're using the inner join, you can put an and then you'll filter in there, or you can simply use it within your where clause if that's what you prefer to do, and you'll get exactly the same results when using the inner join. Okay then, I've prepped a few more examples for you to have a go at and see if you can get your head around the inner join, if it's clear for you or not. So let's go through the examples and we'll take it from there. Number one, the product development team are reviewing our current lineup to see if any changes need to be made to the items themselves. They're after a list of all items and their colors. So you need to write a query to join both the warehouse stock items table and the warehouse colors tables together and return all the data from both. So have a look in the Object Explorer we've got our stock items table there, and we've got our colors table there. So once again, simply highlight the table or do a right click, select top 1000 rows. Here I'm going to highlight the schema table, hit Ctrl 3, and you have a good look at the table. Scrolling along, we've got a color ID. I think we're on to a winner here. Do the same with the colors table, and we've got ourselves a color ID in there. So we know that these two tables can be joined together using the color ID. So write a select statement, joining the two together and selecting everything from both these tables. Let's see how you go. Question number 2 then. Once you've had enough of the first one, desperate times call for desperate measures, and the sales team are looking to boost their end of month figures. If they had spent more time with their customers and less time on the golf course, they would probably not be in this position. But there you have it. And they need some data from you. They're after the data for all customers who have a buying group, and they also need to know what that buying group is. So you need to think about this one a little bit more. Here's our first table. You have to find that on the left. Have a go at that and make sure they have a buying group. So they have to have a buying group. That implies the good old inner join. And we need to know what that buying group is. So pull all the data from both those tables. Let's see how you go. Answers, of course, will be in the next video. Okay then, that wraps up the inner join fundamentals, the second video. We're going to move on to part 3 next, which is all about pseudonyms, what those are and how they are used. So join me in the next video. We'll go over your homework, and until then, everyone, I hope you all have a wonderful day.